Hi, good afternoon, and welcome to our presentation, Step-by-Step Guide for TPMS Service Kits, Sensor Fitment, and more. My name is Doug Kaufman, and I am the editor of Shop Owner and the moderator for this event. Today's webinar is sponsored by Schrader TPMS Solutions. Different rim types call for different types of TPMS sensor fitments, and different sensor fitments call for different service kits. With so many details to remember, how can you make sure that you're choosing the right products and following the correct installation and relearn procedures? During today's webinar, we'll break down how to choose the right sensor and service kit for each rim type. We'll also provide some tips on how to mount and dismount a tire without breaking the sensor. First, though, I'd like to address some housekeeping issues. As part of this webinar, we'll have a Q&A session. Our speakers today will address as many questions as they can during the last portion of the event. Please submit your questions throughout the webinar. To improve the chances of your question being answered, don't wait until the end of the event to submit them. Ask them as they occur to you. To send in your question, just type it in the Ask a Question box and then click the Submit button. This webinar is being recorded and it will be available on demand for you to view. We encourage you to direct coworkers to the recorded presentation. You'll receive an email with a link to the on-demand version in a few days, and it will also be posted on the Tire Review, Tomorrow's Technician, and Shop Owner brand websites. Now, looking at the widget bar at the bottom of your console, you will see icons that allow you to open and close windows on your screen. When you place your cursor over any of the icons, you'll see the name of the widget. You'll notice that there is an icon for Facebook, as well as an icon that lets you send an email to a friend about today's webinar. There's also an option to print a certificate for attending today's webinar. You can access this by clicking on the yellow certificate icon. If you need any help at any point during the webinar, just click the question mark icon for some troubleshooting tips. And to view this webinar full screen on your computer, click the icon with 4 arrows in the upper right corner of the media player window. And finally, if the slides stop advancing or if you're having problems with audio, try pressing the F5 key at the top of your keyboard. This will refresh the webinar console on your screen. Now I'd like to introduce our presenters. We're happy to have Yanick Leduc joining us today. Yanick is the Global Technical Training Team Lead at Schrader TPMS Solutions. His career at Schrader TPMS Solutions began in 2017 when he joined the company as a technical training and support specialist. Since January 2021, he has been leading Schrader's TPMS training team globally. We also have Tom Kirkham joining us today. Tom joined Schrader in 2007 as a technical support hotline specialist and has recently been promoted to technical trainer. He's responsible for their product training and education through multiple channels and platforms, as well as creating content for Schrader Academy, a free TPMS training platform. So now let's get started with today's presentation. Yanick and Tom, the floor is yours.
All right, thank you very much. Hi, everyone. My name is Yanick, and this is my colleague, Tom. We're very happy to welcome you to our webinar today. After our last session back in May, many of you have suggested that we do this next webinar on valve servicing and on TPMS service kit, and we thought it was a great idea, especially with tire changeover season just knocking at our door. So let's jump right into it. All right, so this is our agenda for the next hour. So just so we're all on the same page, we're just going to go through a quick review of basics of TPMS and how Schrader is helping to grow that business. And then we're going to go through the vehicle identification, the service valve, the service back, and the different sensor fitment. So as you probably know, Schrader is known for their valve for, my God, a very long time. In fact, Schrader was actually making valve before cars were invented back in 1844. So, but it's really in 1985 that Schrader engineers started to work on pressure monitoring system. In 1994, Schrader won the OEM contract for the Corvette. And since then, Schrader just continued to innovate and introduce new technologies, new product that meets the need for service technician, tire service technician. As an example, in 2007, Schrader introduced the first rubber snapping valve with a TPMS. And back in 2013, Schrader was the first to introduce in the aftermarket industry a programmable sensor. That also followed in 2015 where we were the first to introduce the single skew programmable sensor. And more recently in 2019, we were the first to introduce a 90-degree sensor for specialty aftermarket rim. But we'll get to talk about that a little later during that presentation. But for now, what is Schrader today? And let me transfer the floor to Tom. So what is Schrader today?
Thank you, Yanick. Schrader is, with all the innovation and engineering invested, it's easy to see why Schrader is the OE supplier of choice today. More than half of the new cars sold today have our sensors in the tires when you drive them off the lot. What that means is that more car builders choose our sensors than any other brand that's available. They choose Schrader because they know our pressure sensors meet the high quality standards that are required by the OE manufacturers, and they know that Schrader sensors represent longevity and quality. Our Easy Sensor family of products is simply the most flexible TPMS sensor on the market today. Our Easy Sensor is a fully programmable sensor, and it covers 99% of the vehicles on the road today with a single part number. So in addition to our OE and our aftermarket OE replacement sensors, we offer fully programmable Easy Sensors. Simply put, the Easy Sensor is the most cost-effective way to get the most complete coverage that's available to you today. In addition to the many advantages that a programmable sensor brings you, the Easy Sensor is the only one on the market today that is available in 3 physically different mechanical packages. We offer the 33500, which is a standard rubber pull-through type valve that will fit nearly any OE stock wheel. We also offer the 33700, which is an adjustable aluminum clamp-in type valve, which is ideal for high pressure or high speed applications. And our 33900, with its 90-degree fit and multiple valve options, will cover most any aftermarket or specialty wheel that you're likely to see. We'll get a little more on that later. So now let's review the ins and the outs of servicing vehicles equipped with TPMS. Firstly, let's talk about how to identify which vehicles have TPMS and which don't. So there's a few distinct indicators that can tell us whether a car is equipped with TPMS. So we'll talk a little bit about those indicators and how we're able to tell the difference between vehicles. So the first and the most obvious way is the TPMS indicator light. You know, that's the yellow light that comes on your dashboard, the tire with the exclamation point. That one comes on when you turn the key to the on position. In addition to the valve stem can also be an indicator. Cars that have aluminum valve stems are easy to spot, right? You have a metal clamp nut on the outside, and that's a TPMS equipped vehicle. But what about rubber stems? How do we tell our TPMS equipped vehicle from a non-TPMS equipped vehicle if the stems are rubber? Well, here's a few clues that you can look for. First is an exposed brass area just below the cap and above the rubber coating. If you have an exposed brass area, that's an indicator that there is a transmitter at the bottom of the sensor. Also, the other two are a raised ridge that goes around the valve or up and down the length of the valve. If the rubber valve you're using has one of those indicators, there is a TPMS transmitter on the bottom. Now, an exception to what you've seen so far would be a banded type sensor, like this type here. This type will have a normal rubber valve, but the vehicle will still be TPMS equipped. Banded type sensors are a design that was used on some Ford and Ford branded vehicles between 2004 and 2013. As you can see, the sensor is not attached to the valve stem itself. The sensor is actually attached to a metal band, kind of like a big hose clamp, that runs around the inside of the rim. The sensor is initially placed directly opposite of the rubber valve so that it's easy to locate. But through regular driving, a lot of times that can rotate around the inside of the wheel, and it makes the sensor harder to find, which means you might have to check multiple locations on the wheel when testing.
So while you're while you're checking the valve to verify if the vehicle is equipped with TPMS, strongly suggest that you also have a check on any pre-existing damage, which is exactly the next point on our agenda. How convenient. So what I mean by that, and I'm sure everyone here has seen that a few times, and I'm talking about those cracked rubber stems or dry out rubber stems. When the rubber material on the valve stem is exposed to the element like rain, sunlight, and high and low temperature, it will cause the rubber to slowly degrade. You can see the impact on the rubber. It will, all dried out. It's going to start to crack. And just a simple crack on your valve stem can be as big as a problem as running over a nail. So you'll want to make sure to do a quick visual inspection of that valve before you start servicing the tires. Same goes for the aluminum valve, the metal valve clamp-in stems. Unfortunately, we see too many of these corroded valve stems. The aluminum valve stem can corrode to a point where the components and sides are seized and bond together. Sometimes it can be even a challenge just to remove them from the rim. It's very important to identify any pre-existing damage before you start servicing the vehicle, because if you break it, well, you're stuck with the problem now. So here's our recommendation. As you check the valve to see if there's a sensor attached at the end of it, you can also identify if there's any pre-existing damage to the valve. You'll want to do that 2-finger twist test. If you cannot remove that valve cap with just your 2 fingers, don't go out and grab that pair of pliers and rip it out. Instead, go and see your customer and let him know that the chrome-plated cap that he put on into his metal stem has created galvanic corrosion. It created corrosion between the cap and the stem, and now the cap is bonded with the stem. You'll try to remove it, but he needs to know that if ever you're dealing with a one-piece module where the stem is permanently attached to the sensor and you break the stem, you're going to need to replace the whole sensor unit. Galvanic corrosion is something you get when you get 2 dissimilar metals. When you mix 2 dissimilar metals and you add a little bit of heat, a little bit of moisture, just like the example we have here. Chrome-plated cap on an aluminum stem is a perfect scenario for galvanic corrosion. But here's another one for you. Galvanic corrosion, as I said, 2 dissimilar metals in contact, creating that galvanic corrosion, chrome-plated cap on the aluminum valve, or what if this one, imagine if you put on a brass-plated valve core inside the aluminum stem. And we see that all the time. Technician will remove the valve core and just put that valve core on top of the tire machine. When it's time to put the air back in the tire, they'll just reach out and grab the first thing they can get and put that inside. It's a common mistake that technicians do when servicing TPMS. Using a brass valve core inside an aluminum stem is another perfect combination for galvanic corrosion. So you'll want to check for pre-existing damage on that valve stem. You want to check if there's any galvanic corrosion outside, but also inside the stem. So there are 2 types of valve core. You have the brass plated core and nickel plated core. Typically, a rubber stem will come with a brass plated core. The aluminum stem or the metal stem will come with a nickel plated core. Now, nickel plated core can go in either or. The nickel will give you a protection against galvanic corrosion. But if you put on a brass core that you took from a rubber stem and you put that into a metal valve, you're creating potential issue for your next visit. You're creating that galvanic corrosion perfect combination. So next time your client will come back for his tire service, there's a strong chance that you'll have a hard time just to take the valve core out of the valve. The good news is you can avoid all that simply by making sure that you service the valve every time that you service the tire, every time that you change the tire. In many cases, these valve failures are due to someone in some shop that did not service the valve last time the tire were serviced or the tire were changed. We're seeing vehicles where they're on their second or third set of tire, but the valve is still the original one. If you don't want to deal with those corroded valve stem and cracked rubber stem, you need to replace the service vac every time you're breaking down the wheel and tire. Service vac, which is exactly the next topic in my agenda. Why is the service vac so important? So first of all, as recommended by the Automotive Maintenance and Repair Association and the Tire Manufacturer Association, the rubber valve needs to be replaced every time you break down the wheel and tire, and the same goes for all the wearable components that's in the aluminum stem. The rubber valve is not expected to last for the life of 2 standard tires in normal service. And the rubber on it, the valve, the seal inside the valve cap, the valve core, they can all degrade over time. So you need to service those valves with a TPMS service pack. Let's start with the rubber snap-in service pack. So what used to be a rubber valve is now a TPMS service pack. You need to make sure that you replace that rubber stem every time you break down the wheel and tire. For the rubber snap-in, the whole assembly comes pre-assembled. Inside the assembly, you'll have the valve, the nut, the cap and the core already pre-assembled inside. The cap, well, most people don't realize that the cap is actually your primary seal of the valve stem. Inside the cap, there's a little rubber seal. And over time, that seal can dry out and crack, creating a potential air leak. At the same time, it creates a path for dirt and road grime away into the valve core chamber. Replacing the sealed valve cap will prevent moisture and dirt from entering the stem and then contaminating the valve core. The valve core is also really important. As I said, it's going to come pre-assembled with a rubber snap-in, but you need to make sure that it's that you're not mixing them up. Heat and compressive force are applied on that valve core. So the rubber seal and the Teflon seal on the valve core can dry off over time. Attempting to reseat an old valve core can create a slow leak. The rubber snap-in will also come with the nut. Now, the nut that connects the sensor body to the valve, it's a self-tapping screw. Therefore, you cannot use it a second time. In order to guarantee a secure connection between 2 parts, you need to use a brand new screw every time. And finally, the valve. So the service kit will come with a full valve. As I said earlier, the rubber on that valve exposed to constant external factor will make that rubber degrade over time. So in order to guarantee safety, you need to replace that rubber valve each time the tire is changed. And for the rubber snap-in, the full assembly comes together, but I want to put on some emphasis on the fact that the fitment. So when you take that service kit out of the bag, you need to be careful. You need to keep in mind that the fitment between the valve and the sensor enclosure, it's a little tricky because the connection between the two can be different. The key at the bottom of that stem needs to match the key in the sensor enclosure. As you can see on that, right next here, each OE sensor has their own TPMS design. So the key used between the sensor body and the valve stem can vary depending on the vehicle manufacturer or the sensor manufacturer. If you want to know which service kit you need to have in order to service that valve stem, you need to look up your service kit part number by make, model, and year. And I really want to stress the importance of choosing the right service kit for the sensor, because Tom and I have seen some, let's say, questionable fitment. Guys, the sensor needs to be firmly attached to the stem. You don't want to be in that situation where you need to explain to your client that the sensor is damaged because it fell off the stem. And as the sensor was bouncing around everywhere in that tire, it also damaged the tire. You can't just fit any valve on any sensor. Trying to cut or to grind the stem in order to make it fit on the sensor, it can cause excessive vibration on that sensor and will cause it to fail. Or we've seen some situation where the sensor could actually just flip around over that valve stem. It needs to be firmly attached and it needs to be fixed. On top of that, the valve and sensor, the valve and sensor design is perfectly balanced. When you come in and you put on just any, if you replace the stem with an unapproved or something that is totally out of spec service kit, it will unbalance the sensor assembly. It can cause radial distortion. When you're driving and the wheel is rotating, it can cause some distortion where you're going to see that sensor that starts forcing upwards or downward. And on the long run, what it can do is going to create some friction on the rubber to a point where the valve can be damaged and cause an air leak. Very important to use the OE specs rubber on that. Aluminum stem is, the metal stem is no different. You need to make sure that you're replacing every wearable component inside that valve stem, and you should never reuse any of the metal stem component after dismounting a tire. The valve cap, just like the rubber stem, the valve cap, it has that seal inside, and it prevents moisture and dirt from entering inside the valve stem and contaminating the seal. You also have the nut and the seat, depending on which type of sensor, type of valve that you have. So the nut needs to be mounted at a specific torque with a torque tool. Every time you torque that nut, it's gonna distort the nut a little bit. If you try to reuse that same nut and put on the same torque, it can crack, or you're gonna end up with you cannot apply the same torque spec on the nut that has been a little bit distorted. So only a new nut will ensure that you have the proper torque spec achieved to seal the grommet on the rim. The grommet is also very important. So that little rubber grommet, when you come to think of it, the grommet is the main sealing gasket between that valve and the valve hole. It's the only thing holding the air in your tire. So the grommet is subject to intense compressive force, and of course is subject to high temperature. Over time is gonna degrade. In order to ensure the perfect air seal, you need to replace that grommet together with all the other components every time you service a tire. And of course, there's the valve core. Again, just like the rubber stem, the rubber cup seal and the Teflon seal on that valve core can dry off over time. Replacing the valve core is vital in order to prevent slow leak. Just keep in mind to always use a brass valve core on a brass stem and a nickel-plated core on the metal stem. So on top of that, for the service kit, don't worry, by looking up make, model, and year, everything will guide you in the right direction. But what you need to keep in mind is with the climp pin, you have different sensor design and different type of valve. So there are two types of, you have the fixed and adjustable angle valve, and you have so that would be a fixed and an adjustable angle, but you also have a one-piece or two-piece design. When you're looking at these different types of sensor and valve from a service pack perspective, with a two-piece fixed angle design, the service kit will include the cap, the core, the grommet, the nut, along with the new stem. A two-piece adjustable angle will have pretty much the same content, in exception to the seat. When you have an adjustable angle, you also need to have that seat that will have the grommet putting in the right position depending on the angle of the sensor. But when you put on a one-piece design, the service kit won't have a new valve stem because the valve stem is permanently attached to the sensor. That means that if you damage that valve stem, you need to replace the whole sensor unit. So as you can see, service pack is not a one-size-fits-all. Aluminum valve pack, the aluminum service pack needs to be, you'll have different components depending on the valve, such as a one-piece fixed angle or a two-piece fixed angle. Always use every component that you'll have in your service pack. The rubber stem, it comes with the full assembly comes with it pre-assembled, but you need to check to make sure that you have the proper key fitment. Always look up your make, model, and year of the vehicle being serviced in order to know what service pack to use. So looking at the service pack is great, but you need to, where do you look for? And what reliable source of information can you get? What do you think, Tom?
Well, I think guesswork's not a real good mix with TPMS. Today, there are so many different types of TPMS valves on the road that choosing the correct fitment is crucial to getting a proper seal, as well as being efficient in doing the job right the first time with the parts available. There are a couple of valuable resources that can help ensure this is done accurately. The search tool on our website, www.schradertpms.com, is the best place to look for TPMS sensor and service kit options. And that'll give you the correct options for the make, model, and year that you've entered. Our Schrader application guide is also a great option. Our guide will give OE as well as aftermarket options based upon, again, the make, model, and year that you're looking up. Okay, so to be sure that you have the parts you need on hand when you need them, we do offer an assortment of the most popular service kits in an easy-to-use single SKU case. Not only does this make storage easy, but it keeps everything neatly organized and easily accessible. Always remember that service components should be replaced every time you service or change a tire using an OEM-validated Schrader TPMS service kit. All components in these kits are intended for one-time use. Now, for simplicity on our easy sensors, we actually use the same rubber valve service kit that's used on a lot of OE service kits. It's literally the same part number. In addition, we offer a complete kit, stem and all, for our 33700 adjustable valve, like this one here. And finally, we have several different service kits available for the 33900, and that's our 90-degree mount. We have service kits that will come in a 90-degree or in a straight. They are available in both silver aluminum and black anodized. And again, service pack components should be replaced every time you service the wheel. And all those components are designed for a one-time use. Okay, so when you've gone through all of those and you still have questions, we have you covered. We're here to support all of your TPMS needs, from part numbers to relearns and everything. We are available from 8 a.m. until 8 p.m. Eastern Time at 800-288-1804, and that does include Saturdays from 10 a.m. until 2 p.m. If you prefer to use email, you can send questions into schraderna@sensata.com. Okay, so let's take a minute and talk about the best practices when you're servicing vehicles that are equipped with TPMS. In the past, we really didn't give a whole lot of thought to removing tire valves, right? I just grabbed a pair of pliers and ripped the valve right out of the rim. With TPMS equipped vehicles, it certainly requires a little bit more care. Some rubber pull-through valves will have a TPMS transmitter at the bottom, and that has to be removed before you can remove the rubber valve. We've also introduced the aluminum clamping valves that require that specific assembly torques and processes be performed. So when you're servicing a snap-in type valve, the first thing you're going to do is remove the valve cap. Remember the two-finger test. We're going to remove the valve core using a valve core torque tool. When you're going to break the bead, you want to place the deflated wheel assembly at the bead breaker. You always want to place the valve at the 6 o'clock or the 12 o'clock position on the front and back beads. Placing the valve in the 6 o'clock or 12 o'clock position will protect the valve from being damaged by the tire machine. Okay, once you've broken the bead, you can place the wheel assembly on the turntable and position the valve in the dismounting safe zone. Safe zone is the space between the dismount post center line and the back of the mount dismount head. And then once you have it placed properly, you can remove the tire from the rim. Okay, so once the tire is removed, the sensor can be disassembled and removed from the wheel. You do that by removing the T10 torque screw at the bottom of the stem, and you separate the valve from the stem itself. And once the sensor is removed from the stem, the bulb of the valve can be cut or just pulled out of the rim using a valve pull. Okay, so just a quick recap on tire dismounting with the snap-in. You want to remove the valve cap. You want to remove the valve core using a valve core torque tool. You want to position the deflated wheel assembly at the breaker. Always remember 12 o'clock and 6 o'clock for the valve position to protect the sensor. Place the wheel assembly on the turntable and position the valve in the dismounting safe zone. That again is the dismount post center line and the back of the mount dismount head. Remove the tire from the rim, top and bottom bead. Once the tire is removed, the sensor can be removed from the wheel by taking the T10 torque tool and removing the stem from the sensor. Then you can remove the valve by pulling that out straight through the valve hole. Okay, so now to service a clamp-in type valve. The first step here is going to be, again, to remove your valve cap, and then remove the valve core using the valve core torque tool. Once you've removed the core, you can remove the valve clamp nut and let the sensor fall inside the tire. Once the sensor has fallen safely inside the tire, you want to follow the very same procedure that was demonstrated previously for breaking the bead with a snap-in valve, as well as dismounting. So you always want to respect your 12 o'clock and 6 o'clock and your dismounting safe zone. Okay, so here's a quick recap on that. We want to remove the valve cap. Remove the valve core using the valve core torque tool, remove the nut, and let the sensor fall inside the tire. From this point, we follow the same procedure as with a snap-in, and we do that for consistency. The last two steps are the exception because with an aluminum, the sensor has already fallen safely inside the tire. Okay, so as you can see as we go through, Schrader offers several TPMS specific hand tools that can make it easy to have the right tool at your fingertips. First is the valve core torque tool. Every time you need to install, you have it handy and you get the torque set exactly right. The universal nut torque tool for installing the clamp nuts, the T20 torque tool for clamp-in valves, and the grommet installation and removal tool.
Okay, so that's for dismounting the tires. And just to make sure that you guys got it, even though we've said it about 15 times during the last 30 minutes, what do you need to do every time that you break down the wheel and tire? You need to service the valve stem, right? Use a TPMS service pack, of course. But just to add in a little bit on that, when installing a new valve, there are 3 general rules that you should be following to ensure that you have the proper valve and sensor fitment. So you have your valve and sensor fitment, fixed angle, adjustable angle, or 90 degree, but that all depends on the rim that you're using. So you have the right TPMS valve. When you put that on that rim, everything is okay if you're sticking to OE specs. So let me go through these 2. The first one I want to show you is the valve must not should not extend over the rim contour. Obviously, if you have a metal valve and this one would extend over the rim contour, you just need to park a little too close to the sidewalk, and then you'll be damaging the valve, ending up with a flat tire probably. So you want to have that valve inside the rim contour. The second one is, in order to avoid any damage to the sensor, you don't want to have that sensor that is directly in contact with the bottom of the rim. If it's directly in contact with the bottom of the rim, through the vibration, you can damage the sensor. So you want it to be flat, parallel with your drop well, but not directly in contact. And the third one is, in order to avoid damage to the sensor when you're breaking the bead, when you're dismounting the tire, you don't want that sensor to exceed over the rim hump. And I have some example of that. So let me just proceed here. So if you keep everything within the OE specification, there's nothing to worry about. If you replace the sensor with an OE replacement sensor and you use an OE spec service pack, everything into a factory wheels, you know that you're keeping the same fitment, and therefore the fitment is nothing to worry about. But if you're dealing with some aftermarket rims or specialty aftermarket rims that has a reverse mount or the valve hole in the middle of the drop well, these types of rim can sometimes use exceptional specification in order to achieve that ultra low profile look. So what do you do with a regular sensor on a aftermarket rim? Let me show you an example that we have here. So here's a two-piece fixed angle sensor with a metal clamping, but it's fitted onto an aftermarket rim where the valve hole flange has an angle larger than 20 degrees. For this type of fitment is not recommended on that rim, because as you can see on the image here, you can see that the sensor is not aligned with the drop well and it's not parallel, and the sensor is exceeding over the rim hump a lot. So you don't want to use that. Instead, what you want to choose is the adjustable angle type. So instead, with a two-piece adjustable angle design, it would be better suited for that specific type of rim, because now the sensor is aligned parallel with the drop well, and it doesn't exceed too much. Now, if you're looking at, that's why we've put on the line in yellow. If you look at this picture for this specific rim, technically the sensor is still exceeding a little bit over the rim hump. And the reason why I've put on that picture in there is, what do you think is going to happen if you put your bead breaker right next to the valve? If you're putting the bead breaker, if you're not doing what Tom was just telling you to do a few minutes ago, and you put that bead breaker right next to the valve, you'll be chopping the sensor right off the stem. You'll be damaging the sensor. So that's why it's really important to always put that bead breaker 90 degrees from your rim. You put the valve at the 6 o'clock and 12 o'clock position, and you have your bead breaker at 90 degrees, avoiding then to damage that sensor if you have a sensor that is on that sort of rim fitment. Here's another one that I have for you. Here's another example for a specialty aftermarket rim that is getting more and more popular. This is a two-piece fixed angle and a two-piece adjustable angle on a 90-degree rim. These types of rim have the valve hole right in the middle of the drop well. As you can see, this type of fitment is not recommended, because they both type will have the sensor that extends way over the rim hump, and you'll be damaging it, even though if you're breaking the sensor at 90 degrees from the rim hump. What you need for those aftermarket wheel that has a 90-degree valve hole, you need a 90-degree sensor. If you use a adjustable sensor, you can only go up to 40 degrees. If you use a fixed angle sensor, usually it comes down to 20 to 20 degrees. But you'll never achieve the 90 degree in order to have the sensor aligned and parallel with your drop well. The only sensor that can provide you that is the 90 degree sensor, like this one here. Now, if I show you the image, okay, there it is. Only the 90 degree sensor design will let you achieve that fitment. So it will be parallel with the drop well, and it will be flat at the bottom. This way, you're able to clear the rim hump. So if you break the bead, it will not be damaging the sensor. And in that case, the sensor is flat at the bottom, not in direct contact with the rim. So we've just reviewed 3 different types of valve and sensor fitment, depending on the rim that is being mounted on. So you have the fixed angle, the adjustable angle, and the 90 degree. These are the same types of valve and sensor fitment that you can find with our Schrader Easy Sensor family of product. You have a 33-500, which is our most popular, the most popular one. It comes pre-assembled with a rubber valve. You have the 33-700 with an adjustable metal valve that allows you for better fitment on most aftermarket wheels. It's also going to support higher pressure and higher temperature. And finally, you have the 33-900, specifically designed for specialty aftermarket rim with that 90-degree valve hole I just showed you a picture of. Now, just so you know, the 33-500, it comes with a rubber snap-in pre-assembled. But if your customer wants to have the metal clamp-in instead of the rubber valve, these valves are interchangeable. You can change that to metal clamp-in with simply by removing the rubber valve stem and getting the separate part 34,000 aluminum metal clamp-in valve, or you can also have the 34010, so the black anodized metal valve, that all interchangeable with that same sensor. What are the advantages other than just having a different look? Well, putting in metal valve instead of the rubber valve, it's really depends on the application that you want to give it. So the aluminum valve, the metal clamping valve will support higher pressure. So instead of having 80 PSI with the rubber valve, it can go up to 115 PSI. And in terms of speed, the rubber snap-in can go up to 115 miles per hour. With the metal clamp-in, you can go up to 155. If you want to go faster than that, which I don't recommend, but you have the 33-700, which we also call our high-speed sensor. 33-700. Now, the electronic inside it's the same thing. Both sensor are compatible the same way with the same tool, can be programmed to the same vehicle. It is compatible with 99% of the vehicle coverage from a vehicle in operation. It is the same sensor, but this one has a adjustable angle instead of having a fixed angle. The advantage of this one, obviously, an adjustable angle so that it can allow fitment on more aftermarket wheels, but it also supports higher speed, where you can go up to 200 miles per hour with that types of design. And if you're dealing with those fuel or black rhinos aftermarket wheels where you have a valve hole in the middle of the drop well, a large offset, reverse mount, 33-900 is the solution for you. You want to have that sensor that allows you to have it flat at the bottom, not in contact with the rim, and that will give you all the, again, Same sensor, just a different mechanical package, compatible with the same tools, can be programmed with the same vehicle, and it's straight, gives you directly on that valve stem. Now it comes with 4 types of valve. You get the straight valve or the 90-degree valve. This is to allow you more clearance with the caliper, depending on, again, what type of rims that you're dealing with. And you can also choose a color between a silver or a black anodized. At this point, it's really just a customer preference. What does he prefer in terms of what does he want to see? So next is, how do you want to mount all that onto your rim? Tom.
So now we're going to talk just a little bit about how to assemble and install both snap-in and clamp-in style valves. Okay, so with the snap-in valve assembly, first you're going to want to thread the valve puller onto the valve. And then you're going to want to mate the valve stem to the sensor enclosure and thread in a new T10 Torx screw. The best way to do that is with a T10 Torx tool that will guarantee you install it at the specified torque. Once you have the assembled valve, first you'll lube the valve stem to install it, then guide the valve through the valve hole, being mindful of proper alignment. While supporting the sensor enclosure, thread your valve puller tool onto threads. Place a rubber step lock between the valve puller and the rim to ensure that you pull the valve straight through the hole. It's crucial that the valve come through parallel to the rim hole. Unfortunately, it's common where you get that on a little bit of an angle, and to do that, it's very easy to put the valve. Once the valve is successfully installed, you can unscrew the puller tool from threads. So just a real quick recap on that: when you're assembling and installing, thread a new snap-in valve onto the puller, assemble the new snap-in valve onto the sensor using the T10 Torx screwdriver, tighten the T10 screw to the correct torque of 11.5 inch-pounds, apply tire lube equally on the rubber snap-in valve, position the valve parallel to the valve hole of the rim, and pull it through using a valve puller and a rubber step lock. Again, please be mindful of the alignment. Once it's installed, you want to check for correct mounting. The valve cannot protrude past the rim contour. The bottom of the sensor must not be in contact with the rim, and the sensor must not protrude over the rim hump. Okay, so now a clamp-in valve assembly. You're going to place the aluminum stem through the sensor body, slide the aluminum seat down the stem, and then you're going to slide the rubber grommet down the stem using the grommet install and removal tool. That's to securely seat it on the stem. Now, when you go to install it, you're going to want to slide the stem through the rim hole, and again, make sure that it is properly aligned with the sensor body facing the rim. Thread the nut onto the valve stem, and then using a torque tool, tighten the clamp nut to the specified torque. So a quick recap on that process is: you assemble the new clamp-in valve onto the sensor, you install the seat, push the rubber grommet all the way down the stem to seat the rubber grommet itself. Position the valve parallel to the valve hole, making sure that the flat part of the sensor body is always facing the rim. And then you tighten the hex nut to the correct torque using a universal nut torque tool. Once it's all installed and torqued, then you want to check for proper mounting. You want to make sure that the valve is not protruding past the rim contour. The bottom of the sensor, again, cannot be touching the rim, and the sensor must not protrude over the rim hump. Right, so after you install the valve, then you can go ahead and mount the tire. You apply lube to both tire beads, push the tire's lower bead onto the rim, and rotate the wheel assembly until the TPMS sensor is positioned in the safe zone. Remember, the safe zone is where the sensor is 180 degrees from the dismount head, depending on the tire size. Sensor wants to be positioned just before the traction point. This is the case for both the top and the bottom beads. After the bottom bead is installed, push the tire's upper bead onto the rim, following the same procedure as in the bottom bead. So once both beads are installed, you want to place the tire in an approved safety cage, inflate the tire to the correct pressure, install the valve core with a valve core torque tool. Remember, if it's a clamp-in aluminum, you want to be sure that the core you're installing is a nickel-plated core to avoid galvanic corrosion. You want to recheck your proper inflation pressure, and then you install the cap. Okay, so just a quick review on mounting to the tire. Apply tire lube to both sides of the tire beads. Press the tire's lower bead onto the rim and rotate the wheel assembly until the TPMS sensor is positioned in the mounting safe zone. Again, that safe zone is 180 degrees from the mount dismount head, depending on the tire. The sensor wants to be positioned just before the traction point. This is the case for both top and bottom beads. After the bottom bead is installed, push the tire's upper bead onto the rim the same way and step 2, respecting the sensor position. Once the beads are mounted, inflate the tire to the correct pressure, install the appropriate valve core and torque it with a valve core torque tool, recheck your pressure, and then you can install the valve cap. Okay, so that's a wrap on the formal part of our presentation. Now we can open it up for viewer questions.
All right, I would like to thank Yanick and Tom for a great presentation. You know, in a few minutes, we are going to have that Q&A portion of the webinar. But before we do that, I'd like to ask everyone to please take a few moments to fill out our survey. The survey should be popping up on your screen momentarily. And if it doesn't launch, you can click the survey icon in the toolbar at the bottom. So now I'm going to kick the questions back to Yanick and Tom to handle the questions that we've received from our audience. Guys, take it away.
So that's the question when we have. Okay. So where do I find a correct service kit part number for the sensor I am working on? Our Schrader TPMS website, definitely. If you want to check that, I actually have a slide on that I can show you.
The best place on the website, we actually have an online search tool on the website. So when you click on the search tool, you can enter the make, model, year of the vehicle, and it will give you all the appropriate part numbers, your sensor numbers, most times the OE number, the aftermarket sensor, and all the service kits that apply to that particular vehicle. And a lot of times it'll actually even have the relearn procedures for when you go to retrain the vehicle.
So when you look up make, model, and year on our website, I just cannot find the slide, but when you look up make, model, oh, there it is. So when you look up make, model, and year on our website, you have, first of all, the sensor part number that it will show you. So I'm, whoops. So you'll have the sensor part number that it can show you right here. And when you click on service kit here, it gives you the service kit part number. You also have the relearn procedure for that specific vehicle that you can check on, clicking on the link right here. All right. Oh, and there's a Schrader mobile app also. Schrader TPMS on Google Play or Apple that you can download. You just punch in make, model, and year on your phone, and it gives you all the part number you need.
Okay. The second question is the mounting procedure the same for all rubber valves? Yes, the procedure is the same. You just want to use a little bit of lube on the rubber valve itself. And the biggest thing with rubber valves is always making sure that you use a step block so that you bring the valve through the hole parallel. You have to bring it straight through. If you get the valve on a little bit of an angle, it's very easy to break it. So the most important thing with a rubber type valve is just make sure that you have that braced with a step block and that you pull that valve straight through and get it properly seated into the rim.
Which valve is better, rubber or metal? Living in North America, rubber, I prefer rubber, but it's not a question of what's better. I think it's more a question of application.
It's more a situation of what you're using it on. more so than which is better. If you're using a high-speed application or a high-pressure application, then the metal valve is clearly a better option. But if it's a normal passenger vehicle under normal operating conditions, a rubber valve is usually fine. So it really isn't a better or worse kind of scenario. It's more just what is more appropriate for the situation and what you're putting it on.
And in both cases, if you don't service the valve, they will fail and you'll end up with a slow leak. Once an easy sensor is successfully programmed, can you program it again? Oh yeah, sensor, easy sensor, programmable easy sensor. You want to answer that one? I have a tool somewhere.
The programmable sensors are not locked in any way, so they're actually rewritable. So if you program them for one vehicle, you can always reprogram them for a different vehicle. So, I mean, the one that's on my workbench in the shop has probably been programmed for pretty much every vehicle out there, you know, on customer calls and that type of thing. But yes, they can always be rewritten. If there's any hiccup in the process, you chose the wrong vehicle accidentally when you were going through the process, I mean, whatever, you just do the process again. It just reprograms it and rewrites the data that's on it.
Yeah, there's no limit to the number of time you can program the sensor. We've been driving around with the same 10 sensors in our case, and we're just, you know, reprogramming them all
Every
over
time you
and
see a new
over
customer, you reprogram it for the
over and over
appropriate
again.
vehicle.
Yes, and because it's wireless, you can actually reprogram them through the sidewall. If you're everything within OE spec, if you're not dealing with too much offset, you can reprogram the sensor through the sidewall. I would say most of the time.
Okay, the next question is, can easy sensors duplicate the sensors already on the car? Okay, so yes, they can. And basically what you would do in that scenario is you would need to have a compatible scan tool like Yanick has here. You would use that tool to scan the sensor that you want to duplicate. The tool is going to grab the data from it, including its specific ID number. And then when you program the easy sensor, what it's going to do is it's going to load in the right communication protocols that the sensor needs for the car, and it's going to take the same ID number that it grabbed from the sensor you want to copy, and it's going to put that ID number onto the easy. So in that scenario, what you're going to have, the vehicle most times won't need to be retrained because it's not going to realize that you've even made a change. It's going to see the same ID number coming in. So yes, a copy can be a very advantageous
well, you get it
option, you know, on certain vehicles that are very difficult to retrain. And there are some, when if anybody in that business, you know, some vehicles are pretty straightforward and some vehicles can have multiple steps. So if you're working on a vehicle that has a more difficult type of relearn, being able to copy the original sensors is really invaluable because it's going to eliminate a lot of potential hangups for you as you go through.
So in the same menu on pretty much all of the tool that Easy Sensor is compatible with, which is pretty much all the tool on the market, you'll have the option between creating a new ID or copying the sensor ID. And even on this one, there's different types of copying. You can copy by OBD or copy by reading the old sensor, but it's all in there. The advantage is you're copying whatever ID was in the old sensor, putting it back, and therefore the car never knows you changed the sensor. Do we have 2-page? Okay, it's the same thing on 2-page.
Yep, guys, I think that's all the questions we have time for today. I would like to thank Yanick, Leduc, and Tom Kirkham for a great presentation. And I'd like to remind our audience that a recording of this webinar will be available on the Tire Review, Tomorrow's Technician, and Shop Owner brands, their websites in the next few days. Feel free to log in to view it again or encourage your colleagues to view it as well. Also, look for a follow-up email directing you to the on-demand version of this webinar. So that concludes our time today. Again, thanks Yanick and Tom from Schrader. Thank you, the audience, for joining us. Thanks for your time. Have a great day.
Thank you.